Use the comparison test to determine whether the following series converges or diverges. So we've got the sum as n equals 1 up to infinity, so just going on and on, of 1 over 2 to the n plus 7. Now when it comes to using the comparison test, we have to compare it to something. We have to compare our given sequence to another one whose series behavior we already understand. Now, does this particular one look like anything, to remind you of anything? Well, kind of looks like 1 over 2 to the n, just with a plus 7 as well. And that is a series that we understand. Right? So it might be a good idea to try and make a comparison. Now, just because you have an idea doesn't mean it's going to work out. But we might start by saying something like, notice that this is geometric. The first term is going to be 1/2, and the common ratio also happens to be 1/2. The first term is only 1/2 because we start at 1. Okay. So this converges. Okay, so we have something we'd like to compare to. We already understand the behavior. Okay, so what can we say? Well, notice that for really any n, okay, it doesn't just have to be n greater than or equal to 1, but really any n, 2 to the n, and this is what's really going to shock you, is less than or equal to 2 to the n plus another positive number. Right? Seems kind of obvious. If you add 7, you get a bigger number. So really, we don't even need the inequality. But we're going to keep it that way. So why are we doing that? Well, 2 to the n is the denominator here. 2 to the n plus 7 is the denominator for the sequence we're trying to understand. And you say, all right. So now if we take the reciprocal, the sign of the inequality flips around. So now the one that we know about, that sequence, is always bigger than the sequence that we are interested in. Okay? And since the bigger series converges, the smaller series has to converge. That's one of the results in the comparison test. Okay? So all we can do is say, by the comparison test, okay, now if the inequality were the other way around for some reason, then this would not be helpful. Showing that the smaller series converges doesn't really do anything for us. So we have to be careful when we construct our inequality. Okay. So this also converges, and we're all done.